Chapter 3, Describing, Exploring, and Comparing Data. The methods and tools presented in this chapter are often called methods of descriptive statistics because they summarize or describe relevant characteristics of data. Lesson 3.1, Measures of Center. Develop the ability to measure the center of the data by finding the mean, the median, the mode, and mid-range. Determine whether an outlier has a substantial effect on the mean and median. Please put this in your notes. Basic concepts of center. A measure of center is a value at the center or middle of a data set. There are several. The mean, or the arithmetic mean, of a set of data is a measure of center found by adding all of the data values and dividing the total by the number of data values. The equation mean equals, x bar is a symbol for mean, equals the sum of x divided by n. There are some properties with the arithmetic mean. The sample mean drawn from the same population tend to vary less than other measures of center. The mean of a data set uses every data value. A disadvantage of the mean is that just one extreme value or outlier can change the value of the mean substantially. All right, so let's calculate a mean. Let's calculate a mean. What if we had some? If we had some data here, let's see. From that airport data speeds, we had 38.5 plus 55.6 plus 22.4 plus 14.1 plus 23.1. And that's the sum of x right there. And in the n, well, we count how many we got. 1, 2, 3, 4, 5, 5. And what does that equal? Well, let's try the old calculator. Let's go to calculator. Control, divide, that gives us that. Fraction bar, 38.5 plus 55.6 plus 22.4 plus 14.1 plus 23.1 over 5, and press enter, and that's 30.74. Okay. Another way to do it would be on, and let's go in here. If you had several of them, you might put them in here like this: 38.5, and 55.6. Especially if you were going to need to calculate other things: 22.4, 14.1, 23.1, and we'll just call this AA. All right, and get it back in it. And menu 4, 1 for stat calculation, 1 for one variable statistics, and number list is 1, and AA. There we go. X bar is 30.74. You get the same answer each way. All right. 30.74. So that's how we calculate the mean. A statistic is resistant if the presence of extreme values or outliers does not cause it to change very much. The mean is not resistant. Okay, notation: N is the number of data values in the sample. Large N is the number of data values in the population. X is the variable usually used to represent the individual data values, and the sample mean, X bar, equals the sum of X divided by N. The population mean is mu equals the sum of X divided by, and that would be the capital N, okay? And that would be all the values in the big population. Make sure you put those formulas in your notes. Median of a set of data is the measure of center that is the middle value when the original data values are arranged in order of increasing or decreasing magnitude. Properties. The median does not change by large amounts when we include just a few extreme values, so the median is a resistant measure of center. The median does not directly use every data value. Finding the median. Sort the numbers in ascending or descending order. If the number of data values is odd, the median is located in the exact middle of the sorted list. If the number of data values is even, the median is found by computing the mean of the two middle numbers on the list. All right, so I guess we need a couple of some values here. Well, we can kind of use those ones that we had, and let's see here. Let's go back here, and let's delete all that. Control, clear. All right, we got all of that out of the way. So we can start up. Now let's see, these are not in order, are they? So what if we, let's see, doc and, or menu, actions, sort, how about ascending? All right, and there we go. Now we put them in ascending order. So let's see here. How many data values you got? 1, 2, 3, 4, 5. Is that all? Yeah, that's 5. So the middle value would be the third one, right? 23.1. Okay, so that would be our median. Now, what if you got a whole bunch of them? Remember, you can do menu, 411, two variable statistic, or one variable statistic, AA, and then the mean is 30.74. And let's go down here. The median is 23.1. All right. Now, let's see here. What if, now there was 5 numbers on it. What if we had 6 numbers on, and then, and let's see, we'll call this B. What if we had 6 numbers? What if we had 14.1, 220.4, 23.1, 24.5, 38.5, and 55.6. Okay. Now we got 6 numbers. Okay, so between 2 and 3, you've got 23.1 and 24.5. So let's see here. If we do it manually, we got control, divide, and we have 23.1 plus 24.5. And then we're going to divide that by 2, and we get, and that's because Mr. Cromer does not know this difference between multiplication and addition. So we'll put a plus in there. There we go, 23.8. All right, that's much better. So 23.8 would be our median. And again, we can menu 411 and okay, and we'll do B, and then we can scroll down, and I'd recommend doing this if you got a whole bunch of them, 23.8. You get the same answer either way. All right. Mode. The value or values that occur or occurs with the greatest frequency. Property. A mode can be found with quantitative data. A data set can have no mode, one mode, or multiple modes. Finding the mode. When two values occur with the same greatest frequency, each one is a mode, and the data set is said to be bimodal. When more than two data values occur with the same greatest frequency, each is a mode, and the data is said to be multimodal. When no data value is repeated, we say there is no mode. All right, how do we go about finding the mode? Let's see here. What if we had some data here? And yeah, what if we had some data here? What do we got? What if we had 0.2, 0.3, 0.3, 0.3, 0.6, 0.6, and 1.2? All right, those are all numbers that we got here. So how many numbers we got? We got 1, 2, 3, 4, 5, 6, 7 numbers, and we've got 3.3s. So this would be multimodal, and the mode would be 0.3. All right. Mid-range is the measure of center, that is, the value midway between the maximum and minimum values in the original data set. Maximum mid-range is maximum data value plus minimum data value divided by 2. Properties. The mid-range is not resistant. Okay. The mid-range is rarely used. The mid-range is easy to compute. The mid-range helps reinforce the very important point that there are several different ways to define the center of the data set. The value of the mid-range is sometimes used incorrectly for the median. So how do we calculate the mid-range? What if, let's see, we had some data a minute ago. And well, let's go back. Let's go back. Let's go back here. What's the largest value? Would be 55.6. And then the smallest would be 14.1. And we would divide that by 2, and we get 34.85. Okay, and that's how we calculate the mid-range. Round off rules for measure of center. For the mean, median, and mid-range, carry one more decimal place than is present in the original set of values. For the mode, leave the value as is without rounding. When applying any rounding rules, round only the final answer, no intermediate values that occur during calculations. Critical thinking. We can always calculate measures of center from a sample of numbers, but we should always think about whether it makes sense to do that. We can always calculate measures of center from a sample of numbers, but we should always think about whether it makes sense to do that. Beyond the basics of measure of centers, mean, from a frequency distribution. All right, here's some data, and we actually used this a while back. We just kind of added to it. So what we're going to do is we're going to calculate the mean from the, and we'll go back and I'll show you just how close it really is. We did this in the last chapter. So we have 75 to 124, and there's 11 of them. So what we need to do is calculate the class midpoint. So how do we calculate the class midpoint? We add 75 plus 124. Let's go over here. On, new, no, calculator. Control, divide, 75 plus 124 over 2, and I did it again. I hit multiplication and I meant to hit addition. Control, divide, 99.5. Okay, so we got 99.5 here. $99.5. Now, the next thing to do is to multiply the frequency by the class midpoint. So we're going to times 11, and we get 1094.5. 1094.5. And then 125 plus 174, control, divide, 125 plus, I did it right that time, 174 over 2, and I did that again, control, divide, 149.5, 149.5, and then multiply that times 24, times 24, and I get 3588. 3588. Now, we're finding the sum of the frequency times the class midpoint divided by the sum of the frequency. Okay, well, all right, so 175 plus 124 divided by 2 is 199.5. Now notice there's a pattern here, right? So I bet the next one's 249.5 and then 299.5. What's the difference between those? Okay, it's the class width, right? And then 10 times, that's going to be 1995. 1995, the year I was born. And then 3 times 249.5 is 748.5. And then 2 times, that would be 599. Now, we got to add up this column here, and this is the sum of the frequency, and that is 50. All right, and then we've got to add up this column here, and this column is the sum of the frequency times x, and then if you add all these up, that's 8,025. All right, excellent, excellent. So now we can go to our calculator, and we have control divide 8025 divided by 50, and we get 160.5. So X bar is 160.5. Now, I wonder, let's check my documents, and I used, if I remember right, McDonald's lunch. No, I don't want to save that other. And let's see here. Menu 411 and one list and AA. All right. Okay. So if you went by the actual data, it would have been 160.24. Okay. Right here, X bar. So it wasn't off by much. Okay. It wasn't off by much. So, and we call this an approximation. The result is an approximation. The actual, based on the real data, X bar based on the real data, was 160.24. So, like I said, it's not off by much, and it's a very, very good approximation. Beyond the basics of measures of center, the weighted mean. The weighted mean, X bar is the sum of the weight times X divided by the sum of the weight. Let's see here. Well, we can calculate we'll call it let's calculate a grade point average. Let's calculate a grade point average. Say, let's see, you've got let's see, the weights, we'll say the weights, or 3, 4, 3, 3, 1, and we'll say your actual, we'll say your grades, your actual grades were A, B, C, and F. All right. Now, let's see. This would translate into X equals 4, 4, 3, 2, and 1, or 0. F is 0. 0. All right. And we would use this formula here. So we've got X bar would be 3 times 4 plus 4 times 4 plus that's 3 times 3 plus, and then we got 3 times 2 plus, and then we got 1 times 0. Okay? And then what are the sum of the weights? Well, 3 plus 4, that would be 3 plus 4 plus 3 plus 3 plus 1. All right? And that equals 43 divided by 14, which is 3.07. Okay? So that's computing a grade point average using weights. Great job, folks. I will see you in class tomorrow, and have a wonderful evening.